20 kilogram box is pushed by a horizontal force of 400 Newton. If the coefficient of kinetic friction is 0.50, find the box acceleration. So this will be the drawing. We have here the 400 Newton push, we have the acceleration, and we have the coefficient of kinetic friction is 0.50. And let's try to identify now the given based on the free body diagram. Now, if you're going to draw the free body diagram, it will look like this. We have the applied force, so we simply label it as F up in an x direction. So we have 400 Newton. And if there's an applied force, it keeps on moving on this direction. We have here the frictional force, which is basically unknown, but we have the coefficient of kinetic friction, which is 0.50. And then we also need to represent the weight, which is mass multiplied to gravity. And since the mass is 20 kilogram, we have to multiply it by 9.8 meter per second square. And then we simply get 196 Newton. That is for the weight. And since it is lying on a flat surface and it is not continually moving down, we have this normal force. Now, based on the required variable, we're looking for the acceleration of the box. Now, how about the equation? For the equation, we simply need to have this frictional force is equals to mu of kinetic multiplied to the normal force. And of course, we also have this basic principle such as F net is equals to ma. But let's try to analyze first the summation of fx. Summation of fx equals to m, or the mass, multiplied to the x direction of the acceleration. So we have here the summation of fx, which is this 400 Newton, or the f up x, minus, since it is pointing on the other side, we have the frictional force is equals to mass multiplied to the acceleration, which is simply the unknown. Solving now, we have this f up x, that is 400 Newton, minus the value of the frictional force, which is still unknown, and the mass is 20 kilogram multiplied to ax. But we can also write for the summation of Fy, wherein mass multiplied to the acceleration through y direction. But since the box is not moving up or down, so the my equals now to 0. So the value of our my, or so the value of our Fy is simply this normal force minus the weight equals to 0. And then therefore normal minus 196 Newton equals to 0. So therefore, the value of the normal force is 196 Newton. Okay. Going back to this equation, we have here frictional force is equals to mu kinetic, which is 0.50 multiplied to the normal force, which is 196 Newton. Remember that we had already solved this normal force, and then therefore the frictional force is 98 Newton. Now, let's go back again with this equation. So we could write now 400 Newton minus the frictional force is equals to 20 kilogram multiplied to the value of the acceleration in the x direction, and 400 Newton minus the frictional force, which is this, that is 98 Newton, and then 20 kilogram multiplied to AX, and 400 Newton minus 98 Newton is 302 Newton. And we have here 20 kilogram times the value of AX. Solving now for the AX, we have 302 Newton divided by 20 kilogram. And then therefore the value of our acceleration is 302 divided by 20. Let me press that in the calculator. And that is 15.1 meter per second square. So how does it become meter per second square? The Newton is equivalent to kilogram times meter per second square divided by the divided by kilogram. Therefore, we have this cancellation of kilogram, and the unit now is meter per second square.